Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome you all in PIST Virtual Learning System session 2020. Hope you all fine and enjoying your virtual learning classes. So dear students, this lecture is for grade first year, subject computer science, and this is our 9th video lecture. And today we are going to start chapter number 2, computer memory. So today we will discuss unit introduction, intro to computer memory, memory characteristics, memory terminology, bit, byte, memory word, and we can discuss the classification on the basis of built-up power and chip memory. So dear students, let's start. After completing this lesson, you will be able to understand the following points. Number 1, define bit, byte, memory word, and memory unit. Number 2, differentiate between main memory and secondary memory. Explain the difference between chip memory and magnetic memory. The next one, differentiate between volatile and non-volatile memory. Then we will describe the internal processor memory, RAM and ROM. Then differentiate between sequential access and direct access memory. Second last is describe magnetic tapes, magnetic disk, and optical disk. In the last, we will describe flash memory and memory cards. So, unit introduction. Computer memory is one of the important and compulsory component of every computer system. This unit describes memory and memory devices used to store data and programs on a temporary or permanent basis for use in digital computer. The two main types of computer memories, like primary and secondary memories, are discussed in this chapter. So dear students, when we talk about the memory, so first of all, what is a memory? So in general terms, memory is the faculty of the brain by which data or information is encoded, stored, and retrieved when needed. So basically, human beings have memory, a brain, where they can save the data and instruction. So just like that, in computer, we have a memory. So in computer, the memory is used to store your data and instruction. As the word implies, memory means the place where we have to store anything. This is very essential part of human being, just like this memory is also very important for computer system, because in computer system, we have to store some data or information, and for storing these items, we need some sort of memory space. So in computer system, we have a memory space where we can save our data and instruction, which we will enter into a computer system through input units. Input units have to be stored inside the computer before actual processing starts. Similarly, results produced by a computer after processing have to be kept somewhere inside the computer system before being passed on to an output unit. Moreover, a computer must also preserve intermediate results for ongoing process. So when you enter some sort of input, so you need a memory to save your data or instruction. When you get your results, so you need some sort of memory where you can put your data or instruction. So memory is very important in computer system. Every time you can use to save your data and instruction. Computer memory is a physical device capable of storing information temporary or permanent basis. So it is memory device utilize integrated circuits and are used by operating system, software, and hardware. So basically, computer memory is just like a human brain. It is used to store data and instruction. Computer memory is the storage space in the computer where data is to be processed and instruction required for processing are stored. Dear students, our system block diagram is used to display the relationship between memory and all I/O devices. So this is our central processing unit, CPU. Input devices, this is our input unit. With the help of input unit and input devices, we can get input and result. After entering input, your result passed to the main memory, and main memory consists of RAM and ROM. And then after getting input, it will pass to the CPU, and CPU will execute the instruction and then send back to the main memory, and main memory send back to output device or output unit for results and information. And also with the help of main memory, we can store our data on a backing storage device. So this is a block diagram and a relationship of a memory and the storage devices with the CPU and all IO devices. So with the help of input devices, we can enter data, and whenever we will enter data, that data needs to store somewhere. That input data, when we will input any sort of data, it needs to store somewhere. So main memory is a place where our data will be saved for temporary basis. Then after getting your results, so also CPU send back your data, and it can be saved for temporarily on main memory and then sent to output device. So this is a relationship between the main memory and all other components. Memory characteristics. The important characteristics of memory devices are its access mode, access time, transfer rate, capacity, and cost. The first is access mode. Memory has two major access modes, sequential and random. So in sequential access mode, memory can be accessed only in serial order. If we have to access fourth memory location, then we first would have to move to first three locations and skip them, and only then we can access the fourth location. This is also called serial access mode. Here access time depends on the location. If location is away from the starting point of the memory, then access time would be more. Like the magnetic tape and the magnetic disk is an example of your sequential access mode. Like in sequential access mode, your data can be accessed in the form of series. You have to go in the form of series if you want to access your data. So data can be accessed only in serial order. If you have to access the 8th memory location, then first would have to move to the first 7 locations and skip them, and only then you can access that specific location. So you have to access all the memory locations, then you can go to the your required memory location. So you have to go in the form of sequence, you can't jump. The next access method is random access method. Any memory location can be accessed at randomly. So means that in random access mode and method, you can access any memory location randomly. If we have to access fourth location, then we can directly go to the fourth location and access it. So access time is independent of the location we are accessing. So means that if you want to open any memory location, that is 4th, 8th, 16th, any memory location, so you can just click on that memory location, you can access directly. So you don't need to go in the form of series. So this method is faster than sequential access method. The next characteristics is access time of your memory. So access time of your memory means that the time a program or device takes to locate a single piece of information and make it available to the computer for processing. Memory access time is how long it takes for character in RAM to be transferred or from the CPU. So access time means that it is the time taken to retrieve data from memory. Access time is sequential access memory devices more than the random access memory device. So it means that it is the time taken to retrieve your data from memory. If you want to retrieve your instruction from the random access memory and from the sequential access memory, so it depends the time taken to access your instruction. This is called the access time. And the time taken in the sequential access devices more than the random access devices. So you can access your data quickly in random access method, and in sequential access method, your time taken is more. Okay, so next is data transfer rate, DTR. The data transfer rate is the amount of digital data that is moved from one place to another in a given time. The data transfer rate can be viewed as the speed of travel of a given amount of data from one place to another. In general, the greater the bandwidth of a given path, the higher the data transfer rate. So data transfer rate means that it is the time taken to transfer data from one memory device to the other. So if you want to transfer your data from the main memory from the any permanent storage, or you want to locate your file from a permanent storage to the main memory, so the time taken to transfer your data is called the data transfer rate, the rate of data transfer. DTR, okay, is the amount of digital data that is moved from one place to another in a given time period, in a specific time period. So for example, time taken to transfer data for hard disk to the main memory. So the time taken to transfer your data from hard disk to the main memory is called the data transfer rate. So you want to transfer your data from hard disk to the main memory, the time your instruction or data will take is called data transfer rate. So generally it depends on your bandwidth. Bandwidth means that how much data can be transferred at one time. So if you can transfer 4 bits or 8 bits, so it depends on your bandwidth and the capacity of your path, given path. So how much data can be transferred? So it depends on your bandwidth. The next is capacity. The memory capacity is the amount of data a device can store at any given time in its memory. So it is called its memory capacity. So the memory capacity is the amount of space. Basically, the memory capacity is the amount of the space that a memory device has to store data, or the amount of memory required for a program to run. So basically, capacity means that it is the amount of space that a memory device has to store data, or the amount of memory required for a program to run. So next we have cost. It is the price that computer users have to pay as per capacity of the memory device. So cost is the price. It is the price that computer users have to pay as per capacity of the memory devices. So if you will increase the capacity of your memory device, your cost automatically it will increase. So if you have more capacity, so it means that you have to pay more. The price of that memory device is more rather than other. Dear students, now I am going to talk about memory terminology. So, bit. A bit short for binary digit. Here, B for binary and IT, it, digit, IT, the last 2 letters of this. So, it is called binary digit. Bit is the smallest unit of data in a computer. Sometimes abbreviated as B, lowercase. Bit is short of binary digit. It is a single unit of information that has a value of either 0 or 1. 0 means off or 1 means on. False or true. Off means false or on means true, low or high. So we can use any term for binary, 0 or 1, off or on, false or true, low or high. So bit means that bit is smallest unit. Basically, bit is the smallest unit which can work with the binary digit and which can work with the computer system. The computer language is the binary language. So your memory location always store your data in the form of bits, the smallest unit. In the form of the smallest unit, we can save our data. Bit, binary, digit. Bit is basically can be represented by 1, 0, 0, 1, on, off. A bit is the atomic, the smallest unit of storage. And bit stores just a 0 or 1. So it can be on or off. It can be 0 or 1. On means 1, 0 means off. True means on, 1, off means false, and 0. So we can use off, 0, false, low in the same purpose. On, 1, high, and true is the same. We can use any term for bit. On, off, 1, 0, 0, 1 like this. So basically bit is a language of 0, 1, 0, 1, the binary language. It is a binary language which can be used to store our data. In the computer, it's all zeros and all ones bits. Anything with two separate states can store one bit. In a chip, electric charge is 0, 1. Means it can save 0, 1, 1, 0. In hard drive, sports of north-south magnetism 0, 1, 1, 0 like this. A bit is too small to be much used. Group of 8 bits together is called a byte. Everything in a computer is zeros and ones. The bit stored just a 0 or 1. It is the smallest building block of your storage. So every time your data is stored in the form of zeros and ones and zeros like this. Basically, the language of a computer is a binary language, and we can save our data in the form of bit. So bit is a short and the smallest unit of data in the computer. A bit has a single binary value. It can be 0 or 1. Computer usually provide the instructions that can test and manipulate bits. They generally are designed to store and data execute instruction in built, and when we will combine the 8-bit bits, so it can make a 1 byte. So it can equal to the 1 byte. When we will combine 8 bits, so it will make the 1 byte. So smallest unit of memory digit in computer is called bit, and bit stands for the digital binary digit, and the abbreviation is binary digit, which we can use to represent the bit, and it can be 0, 1, 0 like this. When we will combine 8 bits, so the group of 8 bits is called a byte. A byte is a data measurement unit that contains 8 bits or a series of 8 zeros and ones. A single byte can be used to represent 2 raised power 8 or 256 different values. A unit of computer information or data storage capacity that consists of a group of 8 bits and that is used especially to represent an alphanumeric character. So basically, the byte is the basic unit of computer memory, and it is the minimum piece of data to be processed by computer. A group of 8 bits is known as 1 byte. 1 byte of memory is required to store one character in the computer. For example, suppose if you want to store A, capital A, small a, or B like this, a byte is generally used to express the memory size of computer. So basically, the byte is used to describe and express the memory size of your computer. Computer memory is measured in terms of bytes. The higher unit are kilobytes. So every time the byte is used to measure your memory units, and we can classify our computer memory in the terms of byte. So suppose here we have a bit. So here we have 1, 2, 3, 4, 5, 6, 7, 8 bits. So the combination of 8 bits is called 1 byte. And the combination of 4 bits is called 1 number. So here we can check the bit is 0, 0, 1, 1, 0, 1, 0, 1. But when we have the 8 bits, 1, 0, 0, 1 like this, so 8 bits is called 1 byte. And when we have 16 bits means that it is 2 bytes, and 2 bytes are called word. So when we have 0, 1, 0, 16 times we have 0, 1, 0, and different combination we have according to our instructions. So it is called a one word. 16 bits is equal to 2 bytes, and 2 bytes is equal to 1 word. So these are the single bit. This is a single bit. It can be a 1 or it can be a 0. So 0 is another a bit. This is another bit. one more bit like this. So we have 8 bits here. 8 bits are combined here, and the combination of 8 bits are called 1 byte. So here we have table. 4 bits is equal to 1 number, means that when we will combine the 4 bits, it will equal to 1 number. And when we have 8 bits, it will equal to 1 byte. After that, the combination of computer memory is measured in terms of bytes. So we can combine all the terms with the help of bytes. Like the higher units are kilobytes, megabytes, gigabytes, terabytes, and petabytes. So we have memory units, and these memory units can be classified in KB, MB, GB, TB, and PB, kilobytes, megabytes, gigabytes, and terabytes. So here there are various units which are used to measure computer memory. The bit is the smallest unit of computer memory, and now we discuss it. The 8 bits are equal to 1 byte, and then we can make the kilobyte, and the kilobyte is 1024. 1024 bytes is equal to 1 kilobyte. A kilobyte consists of 1024 bytes, and it is represented by KB, kilobytes, here from the K and from B from the byte. So it is kilobyte, and 1 kilobyte have 1024 byte. Then we have a megabyte. Megabyte consists of 1024 kilobytes is equal to 1 MB, megabyte. Gigabyte is equal to 1024 MB. Megabytes is equal to 1 GB, 1 gigabyte. Then we have a terabyte. So a terabyte consists of 1024 gigabytes, and it is TB, 1 TB. So we can represent these units KB, MB, GB, and TB. So basically bit is the smallest unit, and then we can get the combination of the bits. So 8 bits is equal to 1 byte, and afterwards we can make the more memory measurement with the help of the byte. So we can measure with the help of the basic unit of your memory. So here we can check kilobyte KB consists of 1000 bytes. 1000 bytes. So you can write 2 raised power 10. It means that we have 1000 bytes in 1 kilobyte. And then megabyte MB. It consists of 1 million bytes. 1 million bytes means that we have 2 raised power 20. 20. So it represents that 1 million bytes. Then we have gigabytes. Gigabytes consist of 1 billion bytes. 2 raised power 30, about the billion bytes. Then we have a terabyte, TB, 1 trillion bytes. So it consists of 2 raised power 40. Then petabyte, PB, 1 quadrillion bytes. So all these are the units of your memory measurement. Nowadays we can measure our memory with the help of MB, GB, TB, and PB. Like we have 128 MB, we have 2 GB memory, like this. So we can measure our memory with the help of these memory measurements. So the next term is memory word. In computing, the smallest chunk or size of data computer can process is called memory word. It is a fixed size piece of data handled as a unit by the processor. The digit of a bit in a word is called the word volume. Word size in modern computers typically ranges from 16 to 64 bits, depending on the size of the computer. The word size can vary from 16 to 64 bits. So do you remember that in the previous slide we discussed that if we have 16 bits, the combination of 16 bits is called one word. 16 bits is equal to 1 word. So if we have 16 bits, it is equal to 2 byte, but is equal to 1 word. So the word is a smallest chunk or size of data that a computer can process is called memory word. Basically, it is a fixed size piece of data handled as a unit by the processor. A computer that has a bigger word size can transfer more bits into the microprocessor at a time for processing, and this improves the processing speed of the computer. The main signal of the word size is how much memory the CPU can address at one time. So basically, a computer word is the number of bytes in a common unit of data defined by the computer system. It is normally the size of a register. The length of a word is different in different computers. The larger word indicates more powerful computers. So 1 byte consists of 8 bits. When we will combine 2 bytes, these are 16 bits, and this is called 1 word. So basically, this is the 1 word, and the minimum limit is 16 bits. The single word consists of 32 bits, and the double words consist of the 64 bits. So basically, the word is a combination of 16 bits and the 2 bytes. Now, I'm going to talk about memory built up and retentional power, the basis on which you can classify your memory. You can define the types of your memory. So first of all, we have a memory. So we can classify our memory on the basis of, you can classify on the basis of built up and retention power. So on the basis of built up, your memory can be classified into, first of all, it can be classified into chip memory, magnetic memory, optical memory. So on the basis of built up, we can classify in 2 categories: chip memory, magnetic memory, and optical memory. And on the basis of retention power, we can classify volatile memory and volatile memory. So it means that how much your data and how much time it can take to save your data. Here we have a built up chip memory and magnetic memory. So these are the different types on the basis of your construction. So all types of your computer memory, as far as their built up or manufacturing is concerned, are divided into chip memory, magnetic memory, and optical memory. So we can work with the chip memory, magnetic memory, and optical memory in many other forms. So first of all, we have a chip memory. Chip is a little part of semiconducting material, typically silicon. A small circuit called IC, integrated circuit, is embedded on it. So you can view here we have a small chip. Chip basically is made of semiconductor material, typically silicon, or this small circuit called IC, integrated circuit. So this is called the integrated circuit. So every chip memory consists of integrated circuit, IC circuit. Like suppose you have a USB. So inside the USB, you have a small chip that is called IC, integrated circuit. A typical chip contains millions of electronic components, transistors. So transistors are basically used to store your data in the form of million electronic components, or these components are called transistors. Chip memories are very fast as compared to other memories, as there are no mechanical moving part in them. But on the other hand, chips rely on electric current. Lots of special purpose chips known as application, particularly integrated circuits, are also being prepared today for automobiles, telephone, home appliances, and other devices. So in all devices, we have some sort of chip memory which is used to hold your data. So chip memory basically is a small piece of semiconductor memory and a small circuit that is called IC. IC is used inside this small circuit board, and this is embedded on this chip. A typical chip contains millions of electronic components. So these components are called transistors. Chip memories are very fast as compared to the memories, as there are no mechanical moving part in them, but on the other hand, chip memories rely on the electric current. We have different types of chip memory which we can use in our daily life, in our routine. So chip memory, first of all, contains the main memory. The main memory is the type of a memory which is used to hold your data on temporary basis. So it can be classified in RAM, ROM, and cache memory. So chip memory can also classify into flash memory card, and register. So all these are the types of the chip memory in which we have ICs. Okay, in memory chip is an integrated circuit ICs made out of millions of capacitors and transistors that can be used to store your data and can be used to process your code. So memory chip, basically your flash memory card, register. So every time we can work with the memory card, we have a memory cards in our mobile phone. Flash memory we are using to transfer our data from one computer to any other computer. So this is your flash memory, USB, data traveler. We can call it data traveler, USB, and the flash memory, which is used to transfer your data from one computer and from one device to any other device. And we can save our data on a flash memory on permanent basis. Memory cards are also used to save your data on permanent basis. So you can hold your data. We can use memory card in our smartphones, in our laptops, and we can use memory card to transfer our data. And registers are used inside the CPU to hold your instructions data inside the CPU. So basically, chip memory is a memory chip which is made up of integrated circuit ICs. Okay, made out of millions of capacitor and transistors that can store data or can be used to process your code. Memory chips can hold memory like temporary or permanent. Main memory and registers are the temporary memory storage inside the computer system, but on the other hand, the flash memory and the memory cards are the permanent storage. So chip memory can be a permanent or can be a temporary. So with the help of permanent through read-only memory, and read-only memory is a type of a main memory which is used to hold your data permanently. So read-only memory contains permanently stored data that processor can read but cannot modify. Memory chips comes in different sizes. So we have different sizes of these memory chips and in different shapes. Some can be connected directly while some need special drives. Memory chips are essential components in computer and electronic devices in which memory storage plays a key role. So basically we have different capacity and different sizes of your memory chip. If we talk about the flash memory, so we have flash memory in different capacity, like we have 1 GB, we have 512 MB. So it depends on your capacity, how much data it can save. So memory cards, so like this, we have a memory cards which can hold and save our data, and capacity always depends on your need. So you have a 1 GB memory card, we can have 2 GB, 4 GB, like this. So it can be vary, and it can be depend on your need. So this is a chip memory which consists of your transistors and ICs which are used to hold your data. Okay,